Okay, so we are starting with our new playlist of sample size calculation. So before we proceed, we can calculate sample size using formulas, using many online calculators which are available. But before we proceed to sample size calculation, we must know our basics. So let's understand the basic concept, like what we need, why we need the sample size, and what do we mean by sample size. So let's assume that we have a larger population. This can be a population of a city, population of a village, or anything. And we want to study, let's say this population was of a city XYZ. Now I want to study prevalence of hypertension in this city, but it is not feasible for me to go and do the study or take hypertension measurement or blood pressure measurement for all the population. So by logic I have to take a small part of it. Okay, so this becomes sample or sample size. Now the process by which we are taking this small sample or sample size from a larger population is known as sampling. And there are many different types of sampling techniques which we may see in the further lectures. So now coming to the sample size. Basically, as we all know, there are two types of data sets, two types of variables which we have. One is categorical and one is continuous. And as we all know, categorical variables are represented as frequency and percentage, while continuous variables are represented as mean and standard deviation, or median and IQR. Now for calculating sample size, basically we need we have some prerequisites which we have to have with us. Okay, so one of the prerequisites is that we should have a thorough ROL before we are proceeding for sample size calculation. So we should have a basic idea, or we should have expected proportion or expected mean or standard deviation available with us from previous studies. So let's say if I was about to do the study of I was about to calculate prevalence of hypertension in city XYZ with the help of ROL, I should at least have a similar study which was done in the same city or in a nearby city or in that particular state or in that particular country, which gives us the existing prevalence or an expected prevalence or expected proportion or expected standard deviation. So the word expected is very important here. And now how we will get this expected is through thorough ROL. So as we were discussing, for sample size, we first have to identify what is our expected thing. Are we dealing with a categorical data or a continuous data? If we are dealing with the categorical data, we may have frequency and percentage, which will be reported as proportion. And if we are dealing with a continuous variable, we may have mean plus minus standard deviation, which is denoted as sigma. So now comes the basic formula, that is Cochrane's formula for sample size, which is n equal to z square pq upon d square for categorical data, and for continuous data it is n equals to z square sigma square upon d square. Here z is constant at 95% confidence interval, and which is 1.96. D is margin of error, which is usually 5%. Now P is expected proportion and Q is 1 minus P or 100 minus P. So as we were saying about the hypertension example, if we have an expected proportion of hypertension of, let's say, 30%, so Q will be 100 minus 30, that will be 70%, and sigma is standard deviation. And mind you, we all will get all this P sigma from existing literature or thorough literature search which we have done. So now let's understand with a simple example. Let's say I had P of 30% as we were discussing. So Q becomes 100 minus P, which is 70. Now if we put this in the formula, so N becomes Z square PQ upon D square, which is 1.96 into 1.96 into 30 into 70 divided by 5 into 5. So this was our basic formula for sample size calculation. Now in many scenarios we have to iterate the sample size as per our requirement. We have to iterate the sample size. So either we'll have to increase the sample size or decrease the sample size. Now how we will do that? So let's first understand the concept of margin of error. So now after a thorough calculation, the sample size comes around to be 322. Now we can vary it, like if we increase the denominator, obviously the n will decrease, that is sample size will decrease. So if we increase margin of error, the sample size will decrease, and vice versa, that if we decrease the margin of error, sample size will increase. In the same way, if we increase the numerator, the sample size will also increase, and vice versa. So these adjustments we have to do, and there are many other adjustments as well which we see, adjustments and like basic about what is margin of error, what is 95% confidence, what is confidence interval, what is power, what is alpha error, and all this. We'll see that in the next video. This was just a start of sample size, and the most important formulas which we have to remember are: number 1, Z square PQ upon D square for categorical variables, and Z square sigma square upon D square for continuous variable. This is the base of all sample size calculation. These two formulas are base for all sample size calculation, and these are known as Cochrane's formulas. So this was it about the basic of sample size. Please stay tuned with us for the next video, where we'll cover all the terminologies, all the basic concepts used in sample size calculation, and in the upcoming videos we will have an hands-on experience with the software as well. Thank you.